Ever wondered how data is transferred over the internet? It's not magic, it's technology. Just like a bustling city, the internet is full of traffic. But instead of cars, we have data zipping back and forth. To manage this data, we have certain tools at our disposal, such as ports, protocols, TCP, UDP, and IP addresses. Think of ports as different doors at a warehouse, and protocols as the rules for how goods should be handled and delivered. Together, they ensure that the right type of data reaches the right place. Now, TCP and UDP, they're like two different ways of sending mail. And IP addresses, they're kind of like your home address, but for your device on the internet. But don't worry if it's all still a bit foggy. We're about to clear things up. Ready to dive deeper? Let's start with understanding ports and protocols. So what exactly are ports and protocols? First, let's talk about protocols. Protocols are like the rules of the road for data traveling across the internet. Imagine you're driving in a bustling city. The traffic lights and road signs serve as your protocols, guiding you on how to navigate the streets and interact with other drivers. Similarly, network protocols manage the flow of data online, making sure information is sent and received correctly. Now let's move on to ports. Think of ports like the gates at an airport. Each gate is designated for a specific flight, and this helps keep everything organized amidst the hustle and bustle. In the digital realm, a port number identifies a specific process or type of service. For instance, web servers typically use port 80 for HTTP traffic, and port 443 for HTTPS traffic. Now, how do ports and protocols work together? Well, they work hand in hand to manage and direct internet traffic. Let's consider the postal system for a moment. Letters and packages are sent to a sorting facility, which uses zip codes and address formats to deliver mail. The zip code ensures the mail reaches the right regional post office, and the street address makes sure the delivery reaches the exact location within a large organization. In the same way, specific protocols like SMTP for email and HTTP for web browsing use particular port numbers to ensure data packets reach their correct destinations. By understanding how ports and protocols function, we can see just how crucial they are for organizing and facilitating the various types of communications and data transfer activities that occur on the internet. This coordination helps maintain an orderly, predictable, and secure exchange of information across diverse and complex digital networks. Now that we understand ports and protocols, let's move on to TCP and UDP. What's the difference between TCP and UDP, and why should we care? Well, let's delve into this fascinating topic. Imagine you're sending a letter. You have two options, registered mail or a postcard. Each has its benefits and drawbacks. Now, imagine TCP or Transmission Control Protocol as your registered mail. When you send a letter via registered mail, you're looking for reliability. You want to ensure your letter reaches its destination, and you want a confirmation when it does. That's what TCP does for data transfer. It's like a diligent postal worker making sure that every piece of data or packet gets from one place to another. If a packet goes missing or gets damaged, TCP will resend it. It's a guarantee that your data will arrive intact, though it may take a bit longer due to these checks and balances. On the other hand, UDP or User Datagram Protocol is like sending a postcard. It's quick, it's easy, and it doesn't fuss over signatures. UDP sends packets without waiting for confirmation of receipt. This makes it faster than TCP, but it also means there's no guarantee your data will reach its destination. If a packet gets lost in transit, UDP will not send it again. It's a bit of a risk taker, favoring speed over reliability. So why should we care about these two methods of data transfer? Well, depending on the situation, one may be more suitable than the other. For instance, if you're streaming a video, you would prefer UDP. It's faster, and if a few frames get lost, it won't drastically affect your viewing experience. But if you're sending a critical document over the internet, you'd want TCP with its reliable confirmation-based system. With TCP and UDP understood, we can now tackle the concept of IP addresses. Have you ever wondered how your computer knows where to send and receive information on the internet? That's where Internet Protocol or IP addresses come into play. Just like every house in a city has a unique address to help the mail delivery person drop off the right packages at the right places, every device connected to the internet has a unique IP address. This IP address is essentially your device's home address on the internet. Without it, your device wouldn't know where to send or receive information. Let's simplify it a bit. Imagine you're sending a letter to a friend. You write your friend's address on the envelope, which guides the postal service to deliver your letter to the right location, right? On the internet, data packets are like these letters. They contain information that needs to be delivered from one device to another. But instead of a postal address, these packets use IP addresses. Now you might be thinking, how does my device get an IP address? Well, when you connect to the internet, your internet service provider assigns an IP address to your device. This address is unique to your device for that connection. When you disconnect and reconnect, you may be assigned a different IP address. IP addresses can be either static or dynamic. A static IP address remains the same whenever you connect to the internet. It's like having a permanent house address. On the other hand, a dynamic IP address changes every time you connect to the internet. It's like staying in a hotel room that changes every time you visit. IP addresses not only identify your device on the internet, but they also enable your device to communicate with other devices. They play a crucial role in ensuring that data packets reach the right destination. Without IP addresses, the internet as we know it would simply not function. Now that we know about IP addresses, let's recap what we've learned. We've covered a lot today, so let's summarize the key points. Firstly, we dived into the world of ports and protocols. Like the traffic lights and signs that guide cars on our roads, protocols serve as the rules of the road for data, ensuring smooth communication between devices on a network. They facilitate a conversation that all connected devices understand, helping to prevent data traffic jams and collisions. Then we introduce ports. Think of ports as the various gates at an airport or doors at a warehouse, each assigned to handle a different type of service or data stream. They help distinguish between the multiple types of data entering and exiting devices on a network, making sure that the right data gets to the right application. When these ports and protocols work together, they expertly manage and direct internet traffic. Much like a mail delivery system where zip codes and address formats ensure that your packages reach their correct destinations, ports and protocols ensure that data packets reach their intended destinations efficiently and securely. Next, we explored the difference between TCP and UDP. Compared TCP to sending a registered mail that requires a signature upon delivery. It's reliable, but it may take a bit longer. On the other hand, UDP is like sending a postcard. It's quicker, but there's no guarantee the postcard will arrive or be resent if it gets lost. Both play crucial roles in data transfer, each with its own advantages and trade-offs. Finally, we discussed the concept of an IP address. Much like the unique number assigned to each house in a city for mail delivery, an IP address serves as a unique identifier for each device on the internet. It ensures that data packets reach the right device in this vast digital city that is the internet. So there you have it. Ports, protocols, TCP, UDP, and IP addresses, all working in harmony to make your internet browsing experience seamless. Each plays a intricate dance of data transfer that happens every time we send an email, stream a video, or simply browse the web. And that's a wrap. Next time you're browsing the internet, remember the intricate dance of data transfer happening behind the scenes. Keep exploring and stay curious.